Hello again, IB peeps. Today we're going to be working on graphing a tangent function. This is probably the most difficult one to graph. It's going to be a tough one to explain. So really make sure today that you're pausing the video as needed. You're really checking the notes. It's going to be graphed a lot differently than sine and cosine functions. First thing I have is the warm up here. I've got the answers, so you guys can pause the video and go ahead and check your answers and see how you did. Once we're done checking our answers, we're going to move on to the worksheet today. Online worksheet number 9, graph of a tangent function. And when we're talking about graphing a tangent function, we have to remember something. The tangent of x, if we're thinking SOHCAHTOA, that's going to be opposite over adjacent. So in this situation, if we're trying to draw a right triangle over here on the unit circle, the opposite side is the y value, the adjacent side is the x value. Remember, angle theta is always formed from the center of the circle. So in this situation, we're talking about y divided by x. And what happens here is the y value happens to be sine of x, and the x value happens to be represented by cosine of x. So another way we could technically write this is sine of x divided by cosine of x. So what we've just created is something called an identity. And that identity is tangent of x equals sine of x over cosine of x. So over the last few weeks of school, we're going to introduce a lot of identities to you, but this is the first one, and this is called the tangent identity. A few important things to remember here are that the sine function is always going to represent all of the y values on a unit circle like this, and the cosine function is always going to represent all of the x values. So it's fair to say that sine of x is always going to be y over r, which we've discussed before. In this case, the r value is just 1, so it's y over 1, or just the y value. And it's safe to say that cosine of x is x over r, where r is 1. So the cosine is the x value, and then we've already discussed the tangent being the y divided by the x. The big thing that we want to look at, though, which really defines a tangent graph, is two situations. The first situation, what happens when sine of x equals 0? The second situation, what happens when cosine of x equals 0? And the way we can think about that is if we wrote tangent of x equals 0 divided by cosine of x. Well, what's anything divided by 0 going to be? It's just going to be 0. So therefore, when sine of x equals 0, tangent of x equals 0. And likewise, when cosine of x equals 0, we can say tangent of x equals sine of x divided by 0. And whenever we end up with a number divided by 0, it doesn't really equal anything, we just say it's undefined. So when cosine of x equals 0, tangent of x is undefined. So in general, let's look at the graph of a tangent function down here. First thing we want to do is say, hey, this is the graph of y equals tangent of x. Okay, the graph of a tangent function looks really weird. The first thing that's going to happen is the period of a tangent function is pi. And the way we can best think about that is if we look back up to our unit circle. If I am using a blue highlighter here, highlighting around the circle, I see that in quadrant 1, I'm going to have positive y values divided by positive x values. Because in quadrant 1, the y values are positive. So this is positive y values. And the x values are positive divided by positive x values. When I get to quadrant 2, it's going to be positive y values divided by negative x values. And what happens is I go from 0 divided by 1 and then all the way back to 0 divided by -1, so I get another equals 0 at 180 degrees there. So now when I get to quadrant 3, I've actually started a brand new period where it's going to be negative y values divided by negative x values, which is going to give me a positive value. And then the last rotation is going to be negative y values divided by positive x values. So that's where the period of pi comes from. So where sine and cosine, one period is one full rotation of the circle. For a tangent function, one period is actually just a half of a rotation of the circle. So it's pi. That's where the period comes from. Okay, vertical asymptotes for a tangent function. That's going to be when the function is undefined. So when cosine of x equals 0. That's what we want to look for. Well, cosine of x is going to equal 0 twice on the graph. It's going to equal 0 at pi over 2 and 3 pi over 2 radians. Or if we're thinking about rotation in degrees, we'd be talking about 90 degrees or 270 degrees. But we're always dealing with radians here, and that's what this image is showing as well. So when we talk pi over 2 and 3 pi over 2. So what happens though, this function goes on forever. So the best way to write it is going to say pi over 2 plus the period of the function times k. And that's really a weird way to write it for vertical asymptotes. But basically there's going to be a vertical asymptote every single time at those values. X equals pi over 2 plus pi over k, where pi is the period of the function. So essentially, whenever you're looking for vertical asymptotes, you have to identify one vertical asymptote and the period of the function, and then you can write your equation. And k is a constant. So what happens is you can say, well, how many periods do we want to deal with? If we want to deal with one period, k equals 1. If we want to deal with 2 periods, k equals 2. If we want to deal with 7 periods, k equals 7. K is a constant that can always be substituted in there. That's a really weird thing to think about. Now for domain, we just take whatever the vertical asymptotes are and we say, hey, the domain's going to be all the values except where the asymptotes are. So in this situation, we'd say x is not equal to pi over 2 plus pi k. That's the good way to write the domain. And we could technically say all real numbers with that. I think that's the best way to write the domain. For the range, as we see the function, it's going to go from negative infinity to positive infinity. So the range is simply going to be all real numbers. So y is an element of all real numbers. So that's a terrible R. We can fix that. We'll say all real numbers. Bam. And x is pi over 2 plus or pi times k. We could also write the range in interval notation, negative infinity to positive infinity. Remember, whichever notation you're most comfortable with is fine. For the x, it's best to write it as x does not equal these values. And you could say x is an element of all real numbers except those values, something like that. That's the best way to write these problems. Okay, some practice here now. We've got 2 examples. It says sketch each function. So just like what we did with sine and cosine functions, we're going to need to identify some key values. So for example, the a value is whatever number's in front. In this case, it's just a 1. The b value is whatever number's inside the parentheses. So in this case, it's going to be 2. The c value would be if there was something being added or subtracted. And in this case, there's nothing being added or subtracted in those parentheses. So the c value is just going to be 0. And last but certainly not least, the d value is anything that's being added or subtracted outside the parentheses, which is usually your equation of the midline. And in this case, the midline is 0. In order to find the period of the function, before, remember for sine and cosine functions, we had to do 2 pi divided by b. Well, in this situation, we're going to have to do pi divided by b because the period of a tangent function, parent function of tangent, is always pi. So we'll say pi divided by 2. And that's it. That would be our period of this function. All right, that's our winning period. Bam. All right, and now we just need to sketch the function. And this one is going to be kind of a weird one to sketch. We start by drawing our x and y axes. Okay. Whenever we sketch these functions, we know that if we put in a 0 first, we're going to start at the very center of the graph. Okay. Next thing we're going to want to do is say, okay, well, the period of the function is pi over 2. So that means if I go out to here and say pi over 2, that's going to be another point where it's going to be at 0, 0. And what happens with the tangent graphs is they're always going to look something like this. Make this nice little shape like that, and then it's going to repeat and do that again. If I went to out here to negative pi over 2, there'd be another dot right there, and we're going to see this exact same graph. Okay, and then there's going to be asymptotes. How far apart are the asymptotes going to be? They're going to be 1 period apart. They're always going to be pi over 2 units apart as well. How you find the asymptotes, this is the hardest part, is you need to identify the asymptotes are halfway between the 2 points of the period. So in this case, halfway between 0 here and pi over 2. So half of 1/2 or half of pi over 2 is pi over 4. So that's where my vertical asymptote's going to be. Halfway between 0 and negative pi over 2 is negative pi over 4. And that makes sense because these asymptotes are also pi over 2 units apart. They're always going to be 1 period of the function apart as well. So the next one would be at 3 pi over 4. And then if I went back this way, I'd say negative 3 pi over 4, and it goes straight down. And the function never crosses the asymptotes. But it is a tangent function, so it's going to repeat forever and ever this way. The next important part is when we talk about the amplitude, we're going to need to label that on our x-axis as well. And we're going to say, okay, well, the amplitude is 1. So we'll say, hey, this goes up to 1. This goes down to negative 1. And the way we can identify amplitude on the graph is going to be right here. This graph is not the most accurate right now. There's going to be 2 points here, and those points are actually always going to be halfway between 0 and the asymptote. So half of 1/4 is 1/8, or half of pi over 4 is pi over 8. And then I would have a negative pi over 8 over here, and that's how I identify where the amplitudes are. The amplitude would be 1 comma pi over 8. So if that number were 2, then the amplitude would be 2 if I were looking at the graph or something like that. But that's how I would identify this key function here. Okay, went through that pretty fast. Let's try one more example that's a little more difficult. We're going to look at example B here next. Starting with example B, I'm going to need to identify those same values, the A, B, C, and D. A is the amplitude. Looks like this one's also going to be a 1. Okay. B happens to be inside the parentheses. It's going to be that 2. C is going to be whatever's being added or subtracted inside the parentheses. So this is going to be pi over 4, and D is going to be whatever number is added or subtracted outside the parentheses, which in this case looks like 0. C is going to be positive pi over 4. Remember, C always takes the opposite sign of whatever you see. And B is going to be 2. I'm a little tight on space here because I drew my first graph kind of big, so I'm going to zoom out just a little bit and scooch over so I can sketch this graph. And this time, I can draw my x and y axes. Bam. I know the amplitude is going to be 1 again, so I can just label that 1 and negative 1. My B value is going to be 2, which this one's another one where the period is going to be pi over 2. The only difference this time from the first one is now I'm shifting pi over 4 units. With that minus pi over 4, it means I'm shifting pi over 4 units to the right. So the whole graph is moving this way, pi over 4 from the first one. which means instead of looking at my left graph where I started at 0, 0, I'm going to want to start at pi over 4, 0. That's where I'd like to start my graph now. And the period is still pi over 2, so I would just say let's add pi over 2. So I know there's going to be another point at 3 pi over 4. And then I know there's going to be another point at negative pi over 4. I know there's going to be another point at negative 3 pi over 4. Okay, and this time, if I were to sketch my function, because the period's pi over 2, my asymptotes are also going to be pi over 2 units apart. So this time, one of my asymptotes I know is going to be at 0. So there's a vertical asymptote. There's going to be another asymptote at pi over 2. There's going to be an asymptote at negative pi over 2. Be an asymptote at negative pi. Every pi over 2 units, there's going to be an asymptote at positive pi. Those are my vertical asymptotes, and I just draw those with the dashed lines. And then the last part is just like we said before. You can find where the values are going to be for the amplitude. It's always halfway between pi over 4 and an asymptote, or halfway between the 0 point and the asymptote. So in this case, pi over 8, negative pi over 8. And again, if my graph were accurate, that point would technically be right there. But my graph's a little off on its accuracy. This one's a little better down here, where it's got kind of got that value where you can see the amplitude. So if I were to ask you specifically on a graph, identify the amplitude, all you have to do is identify these numbers here. And if the number was a 2, then the amplitude would be 2. Hint, hint for example 1 when you guys get to your practice. If the number here was a 4, then the amplitude would be a 4 when you were drawing the equation. All right, so I've got 2 practice problems here. This is the last thing to do today. I want you guys to go ahead and pause the video, try those 2 practice problems. I'm going to post the answers here immediately. All right, finally, a quick look at these last 2 problems. For problem 1, the only difference from the parent function is the amplitude is 2. And as I mentioned before, you would sketch the graph, and the big change you need to make on the graph is just to highlight the 2 and the negative 2 here. We're just going to say, hey, this is 2, negative 2 instead. And we're going to get pi over 4, comma 2 is one value to identify the amplitude. Another one would be negative pi over 4, comma negative 2. That's the big key difference there. For part 2, tangent of x minus 3, we're really just moving the midline to negative 3, but the tangent function is going to look the exact same. The period of a parent function tangent is going to be whoops, I have the b equals 0 written there. It's going to be b equals 1, and the period would just be pi, and the period was pi for both of these functions. All right, so that's how we would sketch these types of functions. Make sure you check your answers, and good luck on the assignment.